This question, we have a spacecraft around in a circular orbit around a planet. Our planet, we will draw like so. We know its mass. And we have a satellite that's a height above the surface. So that's an important distinction here. So the object is on the surface, above the surface, not from the center of the planet. So what information we need to calculate the speed? So this is forces, centripetal forces, gravitational force. So we know the net force from Newton's second law is the sum of the forces, and that is mv squared over r, ma, and it's centripetal acceleration, so v squared over r. And the only force operating here is gravity, which is big G, big M, little m over r squared. We ask ourselves if this little m, which corresponds to the planet, is that the same m here that is experiencing the acceleration? And the answer is yes. So the m's drop out, and we are left with v squared equals g big M r over r squared. R's cancel, so we're left with the square root of gm over r. So what we need to know is the distance between the centers, which is this in red. We need to know the mass of the planet, and that will allow us to determine the velocity. So we know the mass of the planet, good. And we know that height, but we don't, that's not r. So the additional information we need is the radius of the planet. So we definitely need additional information. And it does say that's all we need is the radius. The spacecraft's mass only, the spacecraft's mass dropped out, so we don't need that at all. Both the planet's radius and the mass, no, we don't need either of those. So that's out, and that's why it's choice B.